In this video, we will be explaining everything about the use of portable oscilloscopes in inverter systems. This is a fundamental tool for any technician who wants to diagnose problems in inverter and who knows how to really do it professionally. That he can use it well in front of customers and you will look like a professional. This tool replaces many sample testers, many testers that we may find on YouTube, such as testers with small LEDs or a set of 6 LEDs. This tool replaces that and allows us to give a correct diagnosis. But of course, to use the oscilloscope it is necessary to understand the operation of the parts, as you have already done, for example, when talking about IPM, its operation, its measurements. We need to understand how the system works in order to use this tool. In this video, I want to explain some details about the use of the oscilloscope itself, and not only that, but in the following videos we will be talking about how to acquire it regardless of where in the world you are located. Well, the portable oscilloscope, when we purchase it, comes with its own case. It comes with a fairly hard and firm case that allows us to protect it well. It comes with its instruction manual, which is also in English. I will also be explaining how to use it in this video. Well, the case is very practical. It comes with its charging cable. It is powered by micro USB, its battery is charged by micro USB, and this charge really lasts a lot. Another detail to keep in mind is that it has a silicone case. All of this is included, of course, a completely insulating silicone case that allows us to support it perhaps on the equipment, on the boards, without fear of conduction. On the back, it is well insulated. It has a switch to turn it on, and of course it comes with its measurement cable. This measurement cable has the capacity to measure up to 100 MHz, being sensitive up to that speed, which is the capacity of our oscilloscope, 100 MHz. Okay, if they want to sell you something faster, check the test cable, because they usually come with 100 MHz measurement cables. So if they sell you one with more capacity, check the cable that at the end the limit is 100, usually in these portable oscilloscopes. So, it connects in the following way. We turn the connector until it enters its place. We turn the base pressing a little inwards. It is already connected. This comes loose and we have to insert it when using it. We press well and it stays there. A test tip holds the cable. And it always comes with its 1x10x knob. Whenever we are going to measure voltages of 30 volts or more, we will put it on 10. This activates a resistor so that the full voltage does not reach the oscilloscope and damage it. Whenever we look at much lower voltages, less than 30, we will activate 1x. Of course, if we activate or deactivate the resistor, we also have to inform the oscilloscope. That is why we will press the 1x10x button to be able to inform the oscilloscope that we are using or not using the resistor. So, voltage of more than 30 volts, we activate 10x and we inform the oscilloscope that we are going to use that resistor. So he knows how to do the appropriate calculation to inform us of the measurement. Very well. Other available functions are the variation in the speed on screen, that is, the time that will appear on screen, and the variation in voltage as well. If we are measuring voltages, for example, of 310 volts, as is the case of those of us who use 220 volts, when measuring the output of the IPMs, we will have to increase the voltage to 100. Why? Because each point, each line, each ray we have there, each box will represent 100 volts. 100, 200, 300 and up to 400 gives us the ability to measure. We need a high range. For those who are working with 110 volts, well, they can't go down a little because they only need a limit of 200. 50, 100, 150, 200 is enough for them to put it on 50 volts. Later, the buttons on the side arrows, will change the sampling speed on screen. For example, if we want to see what happens over a second, we will increase the time, 100 microseconds, 200 microseconds, 500 microseconds, 1 millisecond, 2, 5, 10, 20, 50, 100 milliseconds. That means that the oscilloscope on screen will be showing us 100 milliseconds for each box. In total on screen we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 100 milliseconds, that is, 1.2 seconds on screen. There is a lot of information. In fact, if I measured the alternating current in this way, in reality I would understand little, because in 1.2 seconds there are many sinusoidal waves. I will have to zoom in a little, so to speak, and shrink the time displayed on screen to see the sinusoidal waves better. Anyway, if a measurement appears on the screen that you don't understand, when doing a test with the oscilloscope, press the auto button, and the oscilloscope will automatically adjust the time and speed to clearly show the wave. Another important point, use the DC/AC button. If we are measuring the input of electrons through a single cable, configure in DC. If we are measuring alternating current, please place in AC, so that the oscilloscope knows that it will receive electrons from the two cables, both from the positive, which is the test tip with holder, and the negative, which is in the shape of a crocodile clip. Here we have the battery indicator. We also have some details such as the maximum voltage to which the wave we are measuring reaches, peak-to-peak voltage and RMS voltage or average voltage, effective value to know the average power of that wave we are receiving. Do we have more functions? Yes, we have the possibility to stop. For example, what is on screen? That would stop the wave with the stop button. We have other functions that will allow us to see other measurements of those waves and even calibrate in case it is out of calibration. But well, for all this you can later see the link that I leave you. And keep in mind that all these functions are actually useful, but we are not going to use all these functions always. So, keep in mind that you can see more information in the manual that I am leaving you. You can even change the brightness as well. There we are lowering the brightness on screen to consume less battery, if possible. But many times we will use it in the sun, so it is convenient to have the high brightness activated. It looks great. It really looks like a robust, good quality, with good functions device. And the measurements it produces are really accurate, so it is a good tool. The save function saves the image on screen, takes an image which we can then review. It is stored in the small memory that the oscilloscope has. Well, those are some of its functions and how it is used. To highlight and repeat, the most important thing, it is to activate the resistance at 10x or 1x, because it is injected at high voltage without activating the resistance. In other words, if you leave it at 1x, you may run the risk of burning the device. Although it has internal protections, they may burn it and then you have to disassemble it, which is not going to be the most enjoyable, the most appropriate. So, please keep in mind to activate that resistance. Very well, in the next video I will show you some functions of a slightly different model, but very similar.